Gene editing, it's not science fiction anymore. It's really not. The tech to literally rewrite our own DNA is here, right now. And it is forcing us to ask some of the biggest questions in human history. We're not just talking about curing diseases in people who are already alive, we're talking about editing our future before it's even born. So yeah, let's unpack where this whole debate really stands today.
Okay, so we can edit human genes. That part's settled. So the debate has kind of rocketed past if we should do it to prevent terrible genetic diseases and landed on a much trickier question. When should we do it? Do we edit an embryo during IVF before a pregnancy even really starts? Or do we wait and edit a fetus that's already developing in the womb? Now, at first, the answer seems pretty obvious, but you're about to see how the science is making things incredibly complicated.
All right, so let's start with what feels like the safer, more ethical choice. There's a really strong scientific case being made that if we're going to do any kind of gene therapy before birth, doing it on a fetus is a much better strategy than trying to mess with a tiny, few-celled embryo. And the advantages here highlight a super critical distinction. First off, the science for fetal therapy is just, well, it's more developed. But here's the most important point. Fetal editing targets what are called somatic or body cells, not the germline. That's the sperm and egg cells. This means the changes you make, they die with that person. They don't get passed down. And that alone makes it far less controversial and lets doctors be really specific, like fixing a gene just in the liver or only in the brain.
And when you look at it from a purely technical standpoint, the differences are just, wow, they're stark. Studies showed that an embryo's cells are way less efficient at repairing their own DNA, which boosts the risk of serious errors. And think about this. You can easily screen a fetus for mistakes, but trying to do that to an embryo with just a few cells, it's really hard, and you might accidentally destroy it. This all leads to a much higher chance of something called mosaicism in embryos, which is this deeply unpredictable outcome where only some of the cells actually get the edit.
All this is what leads top researchers to argue that editing fetal cells is, for now, simply a far better strategy. It's safer, it's more controllable, and frankly, it's just ethically cleaner.
Seems like a pretty clear-cut case, doesn't it? Fetal editing is the responsible way to go. Well, this is where our story takes a really sharp, unexpected turn. That clean, ethical line we all thought was there, it's starting to get real blurry.
You see, the whole promise, the whole selling point of fetal gene editing was that the changes weren't permanent, they weren't heritable. But brand new technologies are seriously challenging that core idea, blurring the line between what we all thought was a temporary fix and what could be a permanent change to the entire human gene pool.
And the key to this whole blur is a Nobel Prize-winning technology called induced pluripotent stem cells, or iPSCs for short. The easiest way to think about them is as a biological reset button. Scientists can take a regular adult cell, like from your skin, and literally rewind its developmental clock, turning it back into this super powerful stem cell that can become any other cell in the body. And yes, that includes sperm or eggs.
And this technology, well, it creates a pretty shocking new pathway. Just imagine this. Step 1. You edit a skin cell, a supposedly safe, non-heritable edit. Step 2. You turn that edited cell into one of these iPSCs. Step 3. Using a technique called in vitro gametogenesis, which is just a fancy way of saying you're making reproductive cells in a lab, you coax that stem cell into becoming a sperm or an egg. And then, boom, step 4. Your non-heritable edit is now officially in the germline, ready to be passed down for generations to come.
I mean, just let that sink in for a second. An edit that was supposed to be a temporary, personal therapy could now become a permanent part of a family's genetic legacy. That safe boundary we were talking about, it's just gone.
And it's not just some futuristic lab technique we have to worry about. The sources also point out that a developing fetus is just this whirlwind of cellular activity. I mean, there's so much tissue remodeling going on that even a carefully targeted edit aimed at, say, the liver could have some of those edited cells just migrate and get accidentally incorporated into the developing reproductive organs. The supposedly safe edit could become heritable completely by accident.
So if even the quote-unquote safe option now carries a risk of becoming permanent, it forces us to take another hard look at the other side of the debate, embryo editing. If heritable changes are potentially on the table no matter what we do, are there situations where editing an embryo might be the only real path for some people?
Now, it's really crucial we understand a key difference here. Most medicine is about treating sick patients. Embryo editing, it's different. Its main goal isn't to cure someone who's already sick, it's to allow parents who carry genetic diseases to have a child who is genetically theirs, but is also free of that disease. And this is a huge reason why it's still so controversial.
So why is it even on the table? Well, because for a lot of people around the world, other options like using donor eggs or sperm or adopting a child just aren't culturally or even legally available. The sources note that in many Muslim-majority countries, gamete donation is outright banned. And in some Confucian East Asian societies, there can be very strong cultural preferences for maintaining the family bloodline. So for these prospective parents, embryo editing might feel like their only option.
Because of this, what experts are proposing is an incredibly stringent protocol. Seriously, this isn't about choice, it's about a final backstop. The protocol says you must first try to find a naturally unaffected embryo using genetic testing. If that doesn't work, you have to try another entire IVF cycle. And only, and I mean only, if it's biologically impossible to produce an unaffected embryo, only then can editing an affected one even be put on the table. It is strictly framed as a path of last resort.
So, wow, we started with what seemed like a simple question: fetus or embryo? And we've ended up in this world of incredibly complex science and deep ethical minefields, where every single path forward has absolutely monumental consequences. So let's just recap this wild journey. We began thinking fetal editing was the clear winner: safer, non-heritable, ethically cleaner. Then came the twist. Technology blurred that safe line, showing us how pretty much any edit could potentially become permanent. And that leads us to our new reality. Since no option is entirely free of heritable risk, the whole conversation has to shift to one of intense regulation and figuring out what truly constitutes a last resort.
And this really is the heart of the matter. The science of what we can do is just moving at this breathtaking pace, while our ethical guidelines and our laws are desperately trying to keep up. We are, quite literally, building the plane while we are flying it.
And this leaves us with the ultimate question. This technology isn't just about individual families or single patients. It's about the future of the human species. And as these genetic lines continue to blur, probably the most important decision we all face is who gets to hold the pen and write the rules for our collective future.